Hey, Nora, how are you?
I'm good. How are you?
All right. Can you guys hear me? Can you give me an audio check? There we go.
Can you hear me now?
There you go. All right. I know it's coming. Okay. Hey, say hi to everybody. You guys wave? Everybody saying hello to you. There they are. That's how dedicated he is. It is 11:04. Sam, what time is it? There, 11:45?
Yeah, 11:45.
Midnight. Sam's working. Sam's working second shift on us here. Sam, how late do you stay in your classes when you're on Zoom?
How late?
Yeah, how late is it when you get out of your last class?
Like 3 o'clock.
3 a.m. Dude is working second shift. Like he's working the night shift. He's in night school. Hey, so Miller wants to know when you sleep.
Usually 5.
5 to when?
Like 5 to like 3 o'clock in the evening.
Man, Sam, you're a stud, dude. That's crazy. That's crazy. All right. Hey, so welcome to class. I want to start with a brief prayer. Let's pray. God, we thank you for today. Lord, I thank you for Sam and for just keeping him awake to be here with us. And we just pray your blessing on his sleep schedule. I pray your blessing on all of us as we're kind of dealing with some weird stuff all the time right now, it feels like. And I just pray for just clarity and peace right now. Pray for protection and healing for those that are in need of it. Lord, I thank you for the opportunity today that we have to learn. I pray that we would embrace it, help us to live as your people today. In Jesus' name, amen. Okay, we're going to start with a quiz. It is going to be a 12-minute quiz. Yeah, 12 minutes. It is 4 questions, so 2 multiple choice, and then a short, like 2 short answer questions, or 2 short answers. All right, so Zoom crew, I'm sending it to you right now. All right, Zoom, you should have that right now. I'm gonna drag y'all back over here. Okay. So for this quiz, as I hand it out, you can have your formula sheet. I don't necessarily think you'll need it, but you can have your formula sheet if you so choose. Please do not start it. Oh, Wednesday's PSAT. Yeah. let's talk about that after this. Let's talk about that after this. All right. Zoom crew, you guys got it up? All right, 12 minutes. Ready, go. That's it right there. Yeah. Yep. So negative one is perfect. That would this is strong. Yep. Yeah. All right, Zoom crew, you guys all done? exciting times. All right. Go ahead and, there we go. Go ahead and take out your notes. I'm gonna hook up to. All right. What did we talk about last time? Residual. What is a residual? Residual is actual minus predicted. And where do we get these predicted values? Y hat. Why would this be useful? Why not it be useful to predict? In the case that we have a bunch of data, like in two lists, a bunch of data in two lists, why would it be useful to be able to predict that? Tell the person near you. What do you think? What do you think? All right, now out loud. Who's got it? Why is it useful to you to be able to predict, Daniel? Yeah, so instead of having to actually calculate, we can see a trend. We can predict a trend. What's the danger in predicting a trend too far out? What's that called? Extrapolation. You got to be careful of that in statistics. All right. So today we're actually going to look at, and here's what you're going to notice about statistics. Sometimes we're going to do so much with these numbers and then just when you think you can't do anything else, we're going to do yet another calculation. So here we are. Can you guess my IQ? We're actually going to skip down to the notes box for this one. So we're on the one that says, can you guess my IQ? Do you want to do it? We're good. I was going to do that at the end of the review. We're going to do that at the end of the review because I want to see if you can fill in the box notes by yourself. Kind of. I'm not going to catch you. We're going to skip that check your understanding for right now. Actually, you know what? Let's do, let me think. Okay, let's do it. Try to check your understanding on your own. It'll help us prime what we're going to talk about today since we're skipping the activity. We're not going to do the box, but I want you to see what you remember. So we've got backpack weight. Body weight and backpack weight. So we're going to calculate, what's another way to say least squared regression line? That's our y hat. What function or calculator do we use for that? Linear regression. Okay, so let's try this headed into today. show you guys something real quick? Yeah. All right, let me show you something real quick. So let's talk about residuals for just a second. This is going to help us out today. So far, how do we find residuals? Like, describe to me the process for finding the residual. Miller. Exactly. You find the equation, you plug in the explanatory variable, you take that value, that's your predicted value, you take your actual value, subtract your predicted value. Good. Your calculator can actually do this for you. You ready? Okay, here we go. Hit stat. When I go to stat and I go to edit, I have my list 1 and my list 2. I want you to go over to list 3 here. And in list 3, I want you to go up to the very top. Go to the very top. And now what you can do with these lists is when next to the list, if you're up there, you can do operations with other lists. So for example, if you wanted to find the difference between list 1 and list 2, you could put L1 minus L2 and hit enter, and it would calculate it for every single pair. What we're going to do is we're going to calculate the residual for every single pair. So here we go. I want you to hit second. So you're up on L3. You're going to hit second and then stat, which is list. Second stat, which is list. And do you see the residual function? I think it might be function 9. Do you see it? 7, your 7 is 9. Okay, so yeah. No, it's not. Not to get the L1 minus L2, for example. So now I want you to go down to the residual, and select it. And so what should happen now is it might not look like anything, or it might say residual, and now hit enter. Zoom crew, were you guys able to do that? You able to find it? So, is there someone out there that started their residual plot already? Are these matching the numbers that you got for your residual plot? You just did that. And did you know to do this? Ah, okay, that's good. That's good. All right, so if you started to do the residual of every single one, how much work does this save you? A lot of work. And so we're actually going to use that later today, but this can be your residual plot. So let's kind of take this information and use it as a springboard. What did you get for the equation of the least squared regression line here? What do we always start our LSRL with? Y hat equals, what'd you get? Plus 0.091 X. And let's write it in layman's terms. Hat of what? Predicted what? Backpack weight equals 16.26 plus 0.091 times what? Body weight residual plot. What are the features of a residual plot? What is the actual what do the axes look like? What goes in the middle? So here's 0. -1, -2, -3, is that what you say? 1, 2, 3. What goes along the x-axis? What would be a good scale for ours? I'm going to go like this. 100, 120, 140, 160, 180, 200. What are we looking for in a residual plot? Like, why would we want to do this? So a residual plot can tell us if a linear regression is appropriate. So is it important to be accurate? Yes. Is it important to be absolutely down to the minutia, like point dot? No, because what are we looking for? We're looking for a pattern. Okay, we're looking for a pattern. So you want to be precise, but we're also going to give ourselves a little grace here. All right. So hop over to your residual plot. So my first one was -1.16. And that was at 120. So about right here. Next one was -3.24 at 187. Okay. At 109, I know, it's trying to show me up. I actually tied mine this morning. See, what Mr. Knott forgot to tell you was, with all of his years of experience, he's been able to procure the skills to do this. You know what? You can very true. Well said. Well said. I'll check out the video on YouTube. Does that fall in the category of old dog or new dog or tricks? New tricks or old tricks? Right. I appreciate that. I appreciate that. Yes, indeed. Someday. Yeah, he called me fake. But I'm big enough to shoulder the burdens of his insecurities. So 109, we're at -0.16. Can you imagine trying to do this if you didn't have the residuals already there? Yes, sir. You talking about on a residual plot? Yeah. Like you're saying, like do the zeros have to match up? This down here, typically we want to put the 0 line in the middle because it's going to show us if there's a pattern. So he's asking, where does our 0 axis go? It's going to show if there's a positive, negative, positive pattern in that way. Does that make sense? This is kind of a standard notation. There are other ways to write it, but this is kind of our standard notation. Okay, so 103, we're at -1.61. Goodness gracious. 131.84. 165 is 3.75. 158 is 0.38. And 116 is 1.2. All right, so what do you think? Do we have a pattern here? Who says yes, we have a pattern? Who says no, we have no pattern? Doesn't matter. Doesn't matter for this. Look here. Something out there. We'd have to reconsider. Now, so this is where the art of statistics comes in. So that's hard news, right? That's like, well, but what about, so let's say on the test you said this. For number 3, what does the residual plot indicate about the appropriateness of the linear model? And you said, because there's a negative, positive, negative pattern, the linear model is not appropriate. You'd be correct. Let's say you explained it a little bit differently. You said, it appears that there is a random scatter. There's just a single point below the line after our value, which could indicate a potential nonlinear pattern, but the rest of the points are randomly scattered. I can see that too. It's all on how you justify it. But in general, 1 point is okay to make. It's not necessarily an outlier. It's just 1 point is acceptable to make. So what are we going to say here? Because there's a negative, positive, negative pattern, a linear model is not appropriate. So because there's a negative, positive, negative pattern, a linear model is not appropriate. Okay. You ready for the box? Let's talk about the box. First part of the box is going to be divided into 2. Least squared regression line. What's that? Yeah. So write out what least squared regression line stands for. I mean, LSRL stands for. Yes. Good question. We're going to sketch it in the second half of this box. We haven't finished yet. So let's say I added a couple points in here. Like if it was like this. Like if I had if I didn't have this isolated area where there was nothing below, if there were a couple points scattered below, that would be random scattered. They usually try to make it pretty obvious. All right, good. Ready to go? Okay. So least square regression line. It's called this because it's the line with the smallest sum of residuals squared. It's the line with the smallest sum of residuals squared. Why couldn't we just make it the smallest sum of residuals? Why does it have to be squared? We have some residuals that are positive. Very good, Katie. We have some residuals that are positive, some residuals that are negative. We just added them all up. You could have 0, and then you think, oh, my line is perfect. I have 0 residuals. Every point is on the line. But we square the residuals because it tells us how far it actually is. It gives us a distance instead of just a number. All right, next part. Residual plot. Let's sketch. Our residuals go this way, 0 goes in the middle. Our explanatory variable goes along the x. This would be an example of a good residual plot. Because it shows random scatter. We don't have any gaps where there's none below, gaps where there's none above. And we need to remember, of course, that our explanatory, our x goes on this here. And so a bad one would kind of look like this. Because we would have, obviously, that kind of arcing pattern there. So the note that I'm going to make, and I'd like for you to make down here is that we want residual plot show random, let me take out good, random scatter. Make sense? Yeah. It's mask break time. It's time for a mask break. We're going to go outside until 12:33. We're going outside until 12:33. All right, we'll be back. Yes. So I have this thing that I do. I set reminders on my phone for like ideas or words that I have that are like inspire me to like do things a certain way. And so I kind of felt convicted because I'm a really task-oriented person. Like I like to get a lot of things done. I like to take care of things. Sometimes it would be at the expense of in the children's office and be like, hey, good morning. So what's up with this and this and this and this and this? I'm like, first. So it's a reminder to me not to like spend my life like doing things. Well, I appreciate that. It's really a shortcoming of my own, so I'm just trying to fix it. Okay. So, and this is that time right there. Like, I feel convicted because I'm like trying to talk to you guys, and I'm like, all right, now we're gonna do this. Here we go. All right. Scroll down to lesson 3.2. So past the part where it says, can you guess my IQ? Because I kind of already spoiled the surprise for you by showing you residual on your calculator. So we're going to skip to the box here. And basically the activity that we were going to do is calculating a bunch of regression lines, a bunch of residuals, and doing that over and over and over so you can see this. Well, now that you can, like, we understand the concept of residuals, I want to talk about some of the metrics we use for residuals. Imagine a perfect line that had all of the data points on it. What is the residual of that perfect line? They're all zero, right? So if I took all of the residuals at every single point, which are all zero, and I put in a list, and I found the standard deviation of all of those residuals is zero, standard deviation of those residuals is zero. So now imagine a less good data set. Meaning a data set that doesn't fall on first one. One that's got some residuals that are high, some residuals that are low. But let's say it's got a pretty good correlation, like a 0.95. And I take all the individual residual values for each individual point, and I put them into a list. Yeah, 502, no, 501. And 504 was high yesterday too. Yes, sir. Thank you, Johnny. And so imagine I took all of those residuals and I put them in a list. Could I find the standard deviation of the residuals? What would that tell me? It would tell me the average distance from the mean. What mean? Of the residuals. Okay, so not the mean of the original list, not the standard deviation of the original list, the standard deviation of the difference between the actual and the predicted. You tracking with me right now? In statistics, so if a perfect line, she's like, no, I'm not. I said yes, but I'm not. A perfect line, all the data points on the line, has zero as its standard deviation. As you get a less good line, you have more residual, so your standard deviation goes up. So if you're trying to make a prediction, would you rather have a line with a bunch of dots on it, a line with a bunch of dots far from it, if you only knew the standard deviation of each of those residuals? I'd always rather have this, right? I'd always rather have that. So the smaller the residual, the smaller the standard deviation of the residuals, the better off we are. Okay. Fully understanding that 77% of you probably didn't understand a word of that, or you're like, I don't really know. Let's actually talk about this for a minute. That's right. Big ideas. This is a two-parter. Standard deviation. The metric that we put on this is labeled with an S. You're often in statistics going to see SX. That's standard deviation. S is just the standard deviation of just the residual. Here's the interpretation of the standard deviation of the residual. The actual y context, so in the example that we're going to do, the actual backpack weight is typically about standard deviation of the residuals, f, from the number predicted by the least squared regression line. So the actual backpack weight is typically about 5 pounds from the number predicted by the least squared regression line. Does that make sense? So imagine for a second that you are someone who's in charge of production for the iPhone. And so the iPhone 12 is about to come out, right? And so your job is to decide how many do we have to make. Is that a big responsibility? Yes, it is. And so let's say you look back through all the years of data and you came up with this least squared regression line. You're like, I am feeling so good about this. I know I can predict this because I have a line that has a correlation of 0.97. You're feeling really good. Caden's like, I got this. I can do this. I'm the man. And he realizes, though, that in the past, no prediction has been perfect. None has. They've never gotten it spot on, which is okay because it's a prediction. Now, when Caden uses this model to predict the production of iPhones, he looks back and he says, okay, I have S. I know the standard deviation of all my incorrect predictions from the past. And it's okay that he was incorrect because we can't predict right on. I mean, you probably could, but most can't. And he says, I know that in the past, the average distance or the average amount that people have been off is by 45,000 iPhones. So last year, how many iPhones were they off? We don't really know. But over the course of all the years, the average amount was 45,000 off. Does that make sense? You with me? All right. So this is a biggie. You will definitely have to do this on the AP exam. You ready? Coefficient of determinations. The R squared value. Many of you ask me, well, which one do I use, the R or the R squared value? You don't know what the R squared value is until right now. You ready? You will have to do this. Almost assuredly. I'm 89% sure you're going to have to do this. You're going to have to interpret the R-squared value. So they're going to give you the R-squared value. They're going to say, hey, interpret the R-squared value. So you're going to say about 66% of the variability in backpack weight is accounted for by the least squared regression line. What does that mean? What does it mean to account for variability? It has to do with the spread of the data. What else might it have to do with? Think back to Caden's model that he made for the iPhone. Was he ever perfect? Right on the line? No. So least squared regression line, there's always going to be variability, and you want to be able to account for that because you want to be able to say, okay, my line accounts for this. Now, I want a high amount of the data, a high amount of the variability to be accounted for by the least squared regression line, meaning I don't want to have a bad R squared value because then I'm just way off and I don't have it accounted for. So let's look here for just a second. Transfer your least squared regression line from above. It was this. Y hat equals 16.265 plus 0.091x. And that was the predicted backpack weight. Is equal to 16.265 plus 0.091 times body weight. Now, how are we going to find S? I want to find S to do standard deviation of the residuals. What do you think? I'm going to cut you loose on that for about 3 minutes here. Try it. Try to find S. What'd you do? What did you do to calculate S. Yeah, so remember when we put our residuals in list 3? 1 var stats. So we're going to go stat, calc, and then we're going to go 1 var stats. And how do I make sure that I'm calculating the 1 var stats for just the list that I want? You got to put list 3 in. And what did you get for S when you did that? 2 point what? 2.1? Awesome. R squared value. We've actually been dealing with R squared value for a bunch of days. I put the steps down here. Stat calc. Do our linear regression. Make sure your diagnostics are on. What did you get for your R squared value? So 0.632. Somebody give me the full sentence that's not sitting at this table right here. Somebody not sitting at this table right here. The full sentence is how to interpret it. We're on number 3 right now. So R squared value is 0.632. Why not the sentence? Try and interpret. Yep, work on the R squared one. All right, somebody on Zoom. How are you feeling about interpreting this for us? You got us? Who's got us? Don't be shy. Nora, you got us? You kind of got that look like yes. Give me a thumbs up or thumbs down. He says thumbs down. That's okay, it's thumbs down. Let's pop back up to the top. This is how to interpret the R squared value. Let's make a note on that. When we interpret R squared value, this is the sentence we want to use. I'm always really hesitant in my life to tell someone exactly how they have to say something. But in statistics, there's several of these where you know you're going to have to do it, and this is what it means, and this is how you do it. Okay? So this is how you do it. So about R squared percent of the variability in Y context is accounted for by the least squared regression line. That's how we interpret R squared value. Is anybody feeling a tiny bit more confident now? Aditi, how you feeling? You want to go for it? Go for it. She said this. About 63.2% of the variability in backpack weight can be accounted for by the least squared regression line. How's the work? Okay. How are you feeling about this? Are you feeling okay? All right, feeling great. We have about 4 minutes left. Here's your assignment. That's what we do by Friday. It's slightly different than what is on Canvas. It's less than what's on Canvas, which I'm okay with. We didn't get quite as far as I wanted, but that's all right. On Friday, we're going to wrap up by doing the last little piece. It's an exercise, a seesaw exercise. So we're going to see how things balance out. It's on the computer. And then I'm going to give you part 1 of the review. Part 2 of the review will come on Monday. And then Wednesday will be your test. So I got my weeks mixed up, but I want to wrap this up before the quarter. I don't want it hanging over your head like on a Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Like I don't want that for you. So, absolutely. Any questions about that? Yeah. All right, Zoom crew. Any questions? Any questions on anything? Or are you good to go? Talk to me.
Okay, for the R value squared, I don't know how to find that because like my calculator gave me different answers, so I don't know if I did it wrong.
So do you have the display where it says R squared value?
Yeah,
What did you get for your R squared value?
I got like -6.
Okay, so did you make sure to use the data, this one here? Because like those, and then did your list say list 1 and list 2? Or is your X list 1, your Y list is list 2?
That's why my Y list was list 3.
Yeah. So you got to make sure when you go to find R squared, it's always going to be based on the original data, not necessarily, not the residual. The only thing we're going to use the residual list for is to find that S value.
Okay, thank you.
Good stuff. That's great. That's a great question. Anybody else? Questions? I want to answer them. I'm here. I'm available right now. Solo attention right now. All right. Well, if you guys thinking of anything, let me know via email and we will see you on Friday. Okay. Bye-bye, y'all. Have a good one. Enjoy. Yes, ma'am. Yeah. Is that what the back of my head looks like?